Hi guys, so today we're going to look at understanding the distributive property, and we're going to start off by just looking at kind of a physical example, and then we'll get into the math a little bit deeper on the next couple of screens. So understanding the distributive property, let's take a look at Schick's Yummy Soda. We're delivering soda, and we're delivering it to two different stores, store A and store B. So we're going to deliver a case of Fizzy Fuzzy to store number A, and we're going to also give two cases of Fizzy Fuzzy to store B. All right, so one case goes to Fizzy Fuzzy, two cases of Fizzy Fuzzy goes to store B. All right, each case consists of 64 cans. So in each case, there are 64 cans. The total number of cans we could find by using a little math. 64 times 1 plus 2. And what does that really mean? Well, the 1 stands for the one case that went to store A. And the 2 stands for the two cases that went to store B. All right. So then we can distribute that 64 to both those terms, 64 to the 1 and 64 to the 2. So we get 64 times 1. That's what the number of cans were at store A. And at store B, 64 times 2. Well, 64 times 1 is just 64. We multiply 64 times 2 and add them together, we end up with 192 cans. So altogether, Schick's Yummy Soda truck delivered 192 cans to two stores, 64 to store number A and the rest to store number B. Here's another idea for understanding the distributive property. Hot dogs at Callahan's are $2. I don't know about you, I love hot dogs. I know they're not good for you, but I like them, especially Callahan's hot dogs. So on Monday, I bought 4 dogs. On Tuesday, I bought 6. So the question is, how much did I spend in total for hot dogs so far this week? So once again, $2 per dog. Monday, I bought 4. Tuesday, I bought 6. Using our combining like terms or using PEMDAS, we can see that $2 times 4 plus 6. Where did I get the 4 and 6 from? 4 dogs for Monday, 6 dogs for Tuesday. And using PEMDAS, I can do what's in the parentheses. Parentheses first, 4 plus 6 is 10. So I simplified what's in the parentheses, and now what do I do here? I multiply. So 2 times 10 is $20. So altogether, it cost me $20 for 10 dogs. $20 for the 10 dogs I ate over the 2 days. Now, a different way I can look at this problem is to use the distributive property. I could set it up the exact same way. $2 for 4 hot dogs on Monday and 6 hot dogs on Tuesday. But this time I'm going to do it a little bit differently. I'm going to separate them by days. So I spent $2 per dog for 4 dogs on Monday, $2 per dog for 6 dogs on Tuesday. That gives me $8 what I spend on Monday, and I spent $12 on Tuesday. So altogether, I spent $20. Notice the answer ends up being exactly the same. But I calculated it different. Each day was calculated separate, and then these products were added together to find the total or the sum. Each term inside the parentheses was multiplied by the number to the left of the parentheses. So each number inside was multiplied by the 2. That should sound kind of familiar to you. If you think about this, this might be a little hint. What is the 5 in 5x, and what does it do to the variable? Kind of similar idea to this. The 5 is a coefficient. And what does a coefficient always do to the variable it's next to? It always multiplies that variable. Well, in this case, this is kind of like a coefficient, and this is kind of like the variable, right? We're multiplying the number outside the parentheses by the 2 numbers that are inside. So 2 times 4, 2 times 6. I think you guys get the idea. So what do we do when we can't combine like terms? In other words, we can't use the order of operations or PEMDAS. Let's start with an example. Simplify 3 times x plus 10. Since we can't combine the like terms inside the parentheses, what can we do? Well, here's where the distributive property really comes in handy, because you can see x plus 10, we can't combine those two terms. Nothing we can do to put them together. So how can we simplify them? Well, what we can do is distribute the 3 to both terms and then simplify further if we can. So we're going to distribute that 3 to both terms inside the parentheses. Both terms, 3 times x plus 3 times 10. So we distributed the 3 to both the x and the 10. And we end up getting 3 times x is 3x, 3 times 10 is 10. And since we can't simplify anymore, we're done. That's it. We can't combine those terms because they're not like terms. There's no x here. We can't put them together. Let's look at another example. Let's simplify negative 2 times 5x minus 4. Okay, so we're going to distribute that negative 2 to the 5x, and we're going to distribute that negative 2 to the 4. Now notice there's a minus in front of the 4, so I'm going to write that as a negative 4. Remember, the property is really called the distributive property of multiplication over addition. So anytime we distribute, we're going to put a plus in between, and if we have a minus in front, we're going to make it a negative. Okay, it means the exact same thing. And we can talk about that a little bit more in another video if you have questions on that. Okay, negative 2 times 5x is negative 10x. Negative times a positive is a negative. And negative times a negative is a positive. 2 times 4 is 8. So we're simplified. We can't simplify any further. We can't put those two terms together. Binomial, by the way, remember 2 terms is a binomial. Just a little review there. Okay, next one. Simplify 4x plus 6 times 2x plus 1. All right, now you can see, guys, we can't really do anything with the 4x yet because PEMDAS, order of operations, tells us we have to do our multiplying first, and there is multiplying here, 6 times the quantity that's inside the parentheses. So we can distribute the 6 to the 2x, and that's 6 to 1. And now we have to do that multiplying. So we didn't do anything with the 4x, we're just bringing it down. We're going to save that to do later on. That's our next job. 6 times 2 is 12x, plus 6 times 1 is 6. So we did our multiplying. Now PEMDAS tells us, what do we do next? Addition and subtraction. We don't have any subtraction here, but we do have some addition. 4x plus 12x's, well, we have 4x's, 12x's, that's 16x's. So 4 and 12 is 6x's. 16x's in total. Plus we have the 6. Now we can't combine the 6 with anything because we don't have any more constants. We could combine the two variables because they're like terms. But the 6 is not a like term with this because it doesn't have an x by it. So we're simplified. Let's do one final example and then we're done for this lesson. Simplify 5x times the quantity 2x plus 3. So we can distribute the 5x to the 2x and the 5x to the 3 and do our multiplying. Now this one's a little bit more complicated. You have to know a little bit about the exponential rules, okay? 2 times 5, or 5 times 2 is 10. X times x, remember, x times x is the same as x squared. X times x is x squared, x to the second power. Plus 5 times 3 is 15, and there's one x there. We can't forget that x, so it's 15x. Now, we can't combine these two together because they're not like terms, guys. This is a term of x squareds, and this is a term of just x's. So they can't be put together, so we're simplified and we're done. If you have any questions, send me some comments and I'll be happy to address any issues. Okay? See you later. Bye.